Okay, just going to look at solving trig equations with multiple angles, and we'll do it for different boundaries. So first of all, let's just look at 2 theta. Okay, so look at sine 2 theta minus 1 equals 0. We're going to solve that for theta is in between 0 and 360. Okay, so step 1. First of all, you've got to solve for sine 2 theta. So that's 1 on 2. So you just got to solve for the trig equation. Step 2. You need to figure out the quadrant that is in. So it's sine and it's positive. So it's positive in quadrant 1 and 2. Step 3. Now theta is in between 0 and 360. So 2 theta is in between. So times 2 times 2. 720 and 0. So what this means is, instead of just going once around, you have to go 2 times around. Alright, so what you're going to do is you're going to add 360 to each answer. So before we do that, let's just solve. So we're going to solve for 2 theta. So you write 2 theta equals. Now we've got the quadrants, we know it's in 1 and 2. We then have to get the acute angle. So to get the acute angle, you go shift sine minus 1/2. Sine of 1/2 is 30. So in that quadrant it's going to be 30 for the first quadrant and 180 minus 30 for the second quadrant. Now because I have to go around again, I then have to do 180 plus 30 and 180 plus 180 minus 30. So you get 2 theta equals 30, 150, 210, and it's going to be 150 and 360. 11, that's going to be 510, 150 and 360. Yeah, it's 510. Okay, so once you've done that part of it and you've added 360 to each answer, you then have to solve for theta. So your fifth step, the final step, would be divide every answer by 2. So you've got to get rid of the 2 that is in front of the theta. Okay, so 30 on 2, 150 on 2, 210 on 2, and 510 on 2. So then when you solve that, you get 15, 75, 105, 275 degrees. Okay, so that's the first solution. That's the solution to that equation. Now we're just going to look at 2 theta, but this time we're going to solve. Let's go root 3 tan theta minus 1 equals 0. And we're going to solve it for, actually we're going to do a plus. We're going to solve it between pi and minus pi. Okay. Alright, so first of all, step 1, you have to solve for tan. Actually, I want to put a 2 theta in there. Solve for tan 2 theta. So you go, that's minus 1 on root 3. So you bring the 1 over, then divide by the root 3. Okay, then we need to get the quadrants that tan is negative. So tan is negative, so we can see which quadrants it's in. It's going to be in quadrants 2 and quadrant 4. Also the acute angle, so if you did tan the minus 1, now don't put the negative in because you just want the acute angle of 1 on root 3. So that's actually going to be 30 or pi on 6 because we're going to do this in radians. Okay, so that's that quadrant. Now, we know that theta is in between minus pi and pi. So 2 theta would be in between 2 pi and minus 2 pi. So that means that you need to then split it in order to solve it. So you go between minus 2 pi theta it'll be minus 2 pi, 2 theta and 0, and 0, 2 theta and 2 pi. Okay, this one here on the left will mean you're going around in the negative direction. So what you're actually looking at here is minus theta minus pi minus theta, so minus the obtuse, minus pi plus theta, and minus 2 pi minus theta. That's that side. And on this side, we're going around that way, so it's theta, pi minus theta, pi plus theta, 2 pi minus theta. So you're going around the other way. So let's just solve this one here. So you go 2 theta equals, tan is negative here and here. And remember the acute angle was 30, which was pi on 6. So we're going to go minus pi on 6. That's when we hit it here. And then when we come around here, minus pi plus pi on 6. So it's minus pi on 6 and minus 7 pi on 6, and that's 2 theta. Okay, so your next step is to get rid of this 2. So we're going to divide everything by 2. So to divide by 2, you go minus pi on 6 times 2, minus 7 pi on 6 times 2. So that's theta. So theta is minus pi on 12 and minus 7 pi on 12. Okay, this one here. Alright, so we're in that quadrant and that quadrant. So it's pi minus pi on 6, 2 pi minus pi on 6. So that's going to be 5 pi on 6, because that's times 6. 6 minus 1 is 5 times 6. So that'll be 12 minus 1 is 11. So it's 11 pi on 6 and 5 pi on 6. Okay, so your full solution, you don't have to divide by 2, because I've just divided each of these by 2. So it's minus pi on 12, minus 7 pi on 12, 5 pi on 12. Yeah, I've got to divide this by 2 theta, I haven't done that yet. So it's 5 pi on 6 times 2, 11 pi on 6 times 2. So that's going to be 11 pi on 12. So you're kind of attacking the same angle, like this one's getting it here and then there, right? So it does it in 2 spots. They just go in different directions. This one's going to pick it up there, and then when it comes round there in the positive direction, that one's in the negative direction. Okay, so the next thing I just want to look at is 3 theta, and we're going to solve, and we'll do sine 3 theta, and we'll do it when it equals 0. And I'm going to do that for theta is in between 0 and 2 pi. Okay, so let's have a look at that one. Alright, so when I look at that, first of all, it doesn't actually have a quadrant, does it? So it's no quadrants. It's actually a boundary angle. So that, sine is 0 at 0, pi, and 2 pi. Now, because we've got 3 theta, what that means is 3 theta would go in between 0 and 6 pi. So it's times 3 times 3. Okay, so 0 and 6 pi, that means you go 1, 2, 3. So it's 3 times around. Okay, so let's have a look at this. So once you go once around, it's 0, pi, and 2 pi. So if you now add 2 pi to each of these, then you're going to get 0 plus 2 pi, pi plus 2 pi, and 2 pi plus 2 pi. So it will be 2 pi, 3 pi, and 4 pi. But this one's kind of appeared twice. And then I have to add now, I've just added 2 pi to each of those. There. Now what I need to do is I need to add 4 pi to each of those. So go 0 plus 4 pi, pi plus 4 pi, and 2 pi plus 4 pi. Okay, so you end up with 4 pi, that's the first one, 5 pi, and 6 pi. And you notice that that repeats. And when I said that repeats, it means that you keep the original and you don't need to write it twice. So what do we have here? All right, well, we have 3 theta equals 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. And then you just got to get rid of that 3. So if you divide by 3, that would be 0, pi on 3, 2 pi on 3, 3 pi on 3, which is pi, 4 pi on 3, 5 pi on 3, and 6 pi on 3, which is 2 pi. That's your solution to that. Alright, so now what we're going to do is look at pi on 2. So we're going to solve, let's go 2 squared theta on 2 equals 1. Okay, and we're going to do it for theta is in between 0 and 2 pi. Okay, so what would we do for this? There's the equation. Alright, so first of all, we have to solve for our trig function again. So 2 cos squared theta on 2 equals 1, cos squared theta on 2 equals a half, cos theta on 2 equals plus or minus 1 on root 2. Okay, so that means that it is in every quadrant. But there's a little bit of an issue here because theta is normally in between 0 and 2 pi. If you just check your boundary, that would mean 0 on 2, theta on 2, and 2 pi on 2. So the 2's go out. So 0 is in between theta on 2 and pi. What that now does is it just reduces it to those first 2 quadrants. You could solve for all of them, but the last 2, which is these 2 here down the bottom, they'll end up being out of the domain because when you solve, you're actually solving for theta on 2 and you'll have to get rid of the 2 by timesing by 2 and it'll push it out of the domain. Okay, so let's just get the acute angle. So the acute angle, so it's plus or minus 1 on root 2, so that would be 45. Because if you did sine the minus 1 of 1 on root 2, you get 45 degrees or pi on 4. Okay, so now we're going to go theta, pi minus theta, and so you could do pi plus theta and 2 pi minus theta, but they'll actually be outside the domain. Okay, so we go theta on 2 equals, so that's pi on 4, pi minus pi on 4, and I'm just going to put these in so I can show you they are actually out of the domain, but the ones that will be in the domain we will keep, and that'll just be your first 2 here. Okay, so continuing with this, theta on 2 equals pi on 4. If you times that by 4 and that by 4, 4 minus 1 is 3, so that's 3 pi on 2 on 4 times 4 times 4. 4 plus 1 is 5 pi on 4 times 4 times 4, so it's 8. 8 minus 1 is 7 pi on 4. So now you've got this 2 here, so you times everything by 2. They cancel, so theta equals 2 goes into 4 twice, 2 goes into 4 twice, 2 goes into 4 twice. So you go 7 pi, oh wait a minute, what was that one? 2 goes into, the timesing by 2. Alright, so it'll just be pi on 2, 3 pi on 2, 5 pi on 2, and 7 pi on 2. Okay, now you notice that these 2 here, so that's 3.5 lots of pi. Okay, and so that's like way out of the domain because it's got to be between 0 and 360. And this one here is the same. So this is 5 lots of 90, which is 450, so miles outside the domain. See, that's why you always just take the first two quadrants because of this. Okay, when you divide by 2, when you divide 2 pi by 2, you actually only need the first two quadrants, and that would be your that's your solution to this equation. That one there.